So when dealing with solutions, we have a calculation called molarity that we have to look at. So how do we do molarity calculations? What is it? What's the point of it? Well, basically the point of molarity calculation is really to calculate the concentration, or really molarity, of a solution. And what that means is that when we think about concentration, is how much stuff do you dissolve, or did you dissolve, in solution, right? So it's really looking at how much solute you're dissolving in solutions. Let me just get my pen here. So this is the equation, mathematical equation for molarity. It's equal to moles divided by liters. So it's really the solute divided by your solvent. So solute is sort of like your solid stuff. I'm just going to use this term loosely because it doesn't have to be solid, but most of the time it is like your solid stuff, and your solvent is your liquid solution. So it's just like dissolving your NaCl, your salt, into water, or your copper 2 chloride. But solid and solvent can both be liquid. But in this term, let's just use this loosely and just think about like molarity as in your solid divided by solvent, or solid divided by liquid. And the key thing is, once you have this, if you look at this formula, is that molarity is equal to moles over liters. So if you actually solve for moles here from this equation, you can figure out what grams is, what the particles is, and what other things you can convert with moles. So this molarity is very useful, but this is all about solutions. So you're making a solution out of it. So let's look at an example question here. So a 0.5 liter HCl hydrochloric acid solution has 6 molar in molarity. How many moles are present? So this is your molarity formula. So let's just kind of plug all this stuff in. Right now I'm given 6 molar in molarity in this 0.5 liter solution. So I know that this is now, it's instead of 1 liter, this 1 liter is your standard calculation formula, but it can vary depending on your situation. So in this situation, this is 0.5 liters, and you have 6m for molarity, and you're trying to find moles, so that's your unknown. And once you set this up, you know that it's just cross multiply. So 6 times 0.5, so this is 6 times 0.5, this is going to equal to x, and so you have 3.0 is equal to your moles. And if you're wondering how did I get this unit moles, so if I were to break this down into the little steps, 6 molarity is really 6 moles divided by liter, and I'm multiplying by 0.5 liters. This is equal to x. The liters cancel out. My moles is my final unit. That's where I get moles as my final unit. All right. So let's look at a second example here. What is the molarity if there are 3 moles in a 200 ml solution? So again, you can change this liter, the volume, however much you want. The standard formula is moles per 1 liter. So in this case, if we were to put this, molarity is my unknown, because we're trying to find molarity, is equal to moles. So we know that we are given 3 moles and 200 ml. So this bottom unit, the liters, it has to be in liters. So we have to convert this milliliters to liters, and since milliliters to liters is just dividing this by 1,000, your liters is 0.2 liters. So I'm going to put this over 0.2 liters. So the answer here for molarity is that you're going to have 15 moles, or 15 molarity. So that's going to be your 15 moles per liter. So it's a pretty concentrated. If you think about this, this is 0.2 liters, you have 3 moles of it, and if you remember, 1 mole has lots of stuff, so you're going to have a small beaker about 0.2 liters, so 200 mLs, and you're going to have tons of solute in there, so making your solution very, very, very concentrated. That's what you are doing. Let's look at a third example here. You dissolve 20 grams of sodium hydroxide in a 500 ml I guess, solution. What is the molarity? So you're basically trying to find the concentration of this if you divide by 20 grams of NaOH. So first off, you can't do anything with grams. You have to convert. So I'm going to have my 20 grams times the division bar. I'm going to put grams at the bottom and moles at the top because this is my molar mass. The molar mass of sodium hydroxide is going to be your sodium plus oxygen plus hydrogen, and you're going to get a rough mass of 40.0 grams. I rounded those numbers. And this is all over 1 mole because this is the molar mass, grams per 1 mole. So I'm going to divide this, and you're going to see that I'm going to cancel my grams, and my moles is that I'm going to get 0.5 moles of NaOH. So once you have established your moles, then you can plug it into your molarity. So I'm going to have my molarity is equal to, I have 0.5 moles, and this is going to be, now this is my volume. I need to change this to 0.5 liters. So I'm going to divide this by 0.5 liters, and my final answer, if you punch this calculator, is that you're going to get 1 capitalized M for 1 molarity of NaOH. So this is the solution that you want, and that's what you made. So that's your molarity calculation, and that's your formula. How this is important is that when you start to make solutions, when you're trying to working in a lab, trying to make solutions, this molarity formula is very important because that helps you determine how many moles you need. And again, once you have moles, then you can figure out how many grams of the substance that you need. So that's your molarity type question, and thanks for watching.